Howdy folks, how you doing today? Oh, there, just missed the pause. Hope you're doing all right. It's been a bit of a weekend for me. I'm sorry. I'm got some kind of nasty cold going on here, so I was out pretty much all of yesterday. I took some cold medicine, so I'm feeling a little bit better today. I was trying to go without it because it made me like super loopy. That I wasn't even allowed to have class yesterday afternoon. I was just so out of it, but the coughing and the congestion stuff got so bad I took some again. So I'm gonna try not to be so loopy. We'll see how it goes. If things need to slide a little bit, we need to spend a little more time on classes. I think that's okay. I think we'll do all right, and we can kind of bump things as we need to. We'll see how that goes for us. So we're gonna talk about the project, and we're gonna talk about Chapter 7, and we're gonna talk about the practice midterm today, and I think that's what we've got on tap. Let me take a look here real quick. I've not got to your project ones. I'm so sorry. That was on my to-do list, and it just hasn't happened with me getting sick and stuff. So So I'll be working on those as soon as I can. I'm sorry they're running so late. Probably not tonight because I'm going to go to bed as soon as this class is done, but hopefully tomorrow I'll get some more time to work on those and I can get caught back up. So we do have the lab for methods, and then we do have the project. So we can talk about the lab first, and then we can talk about project too. Does that sound good? And we'll move into the new stuff, and then we'll do the practice midterm things from there. All right, so we're just working on our lab 4 code and kind of expanding it to use methods, and we'll go from there. So let me find our lab 4. I think I had it in there, and I'll copy it to be lab 5, maybe. Maybe I'll do that. So we want 1500 winter on Tuesdays for lab 4, and then I'll start up in lab 5. Is that easier than me? You don't want me to just change lab 4. This is probably fine here. New project. I'll just have them both open. We'll call this one lab 5. Make sure we put it in the right folder here. 1500 winter on Tuesdays. All right, usually I can get to that mute button if I've got a cough. I'll let you know. Oh, I forgot to grab my water. I might go grab a water in a minute here. I'm going to need some more fluids. And then we'll see how it goes. I don't want to miss, I canceled the Monday class because we meet twice a week, so I feel like we can still jam in some of it, but if we miss an entire week here, that's a bit. Excellent. All right, I'll be right back with some fluids. Thank you. Yeah, I'll go get some. Let me put some music back on for you, and I'll be right back. We gotta mute this. All right, I'm back. Sorry about that. Got a couple fluid options too. We'll see which one works better. This one is a orange LaCroix. Let's see how well that one goes. Definitely a hint of orange, just the essence of orange, right? All right, so we're going to take lab 4 essentially and redo it with methods. All right, so we grab our lab 4 code here. Take everything in main here. And look at that, we even had a prompt for int value. So we started off with that as our hint. Come into lab 5, I'll paste this in. And yes, we want to add our scanner import. That's really handy when you copy paste stuff. And because we're going to show good habits here, I'm going to go out to our GitHub repository and we'll cite our source here. So I can go find the link here on GitHub. Lab 4, lab 4, lab 4, and I'll copy this in and say started from here. That's a great citation, right? If you are taking a chunk of code from somewhere, let's go for it, right? All right. So we're going to add the other triangle shape, right, for lab 5. We're going to add our equilateral triangle. We'll add another shape here that is a valid shape, perhaps. Say, and not shape equal ignore case. How about we just say equilateral triangle? Man, that's a big thing to type here, but that's fine. And then maybe we'll make this one a right triangle. Okay, sure. Then we want right triangle or equilateral triangle. I'm just going to copy paste that. I don't have to type that again. We don't want to type that again. Okay. Maybe if we do them all lowercase, that's probably a little nicer here. All right, but now we want to start turning this stuff into methods, right? So the idea with our methods here then, right, starting to use methods everywhere, a method for each input prompt and a method for each shape printing. So if we say, hey, prompt for an int value, given some prompt here, right, we can use this then everywhere we're asking for particular values. So this could even be a method here, which is pretty handy. So we'll call this, how about prompt for shape? Prompt for shape. And then we write a method for it, so public static, and we're going to return a string. So our type here is string, we'll say prompt for shape. You know, this one then can just say, hey, my shape equals, a string for shape equals nothing. And then as long as it's not a square, rectangle, right triangle, or equilateral triangle, we'll keep doing these things. Oh, we need the scanner too. So we'll copy paste our scanner in here. Once we get out of this loop, we can return the shape value because I know it gave me one of these values. So this now is a method then that prompts for the shape and does all that validation for us. We can say, okay, sure, here's the shape. Okay, and then we had, okay, if the shape was a square. So now we're going to use that prompt for int value here. Given the prompt, we have to tell it what string is our prompt here. So we can say, all right, so I want to have an int for size is equal to prompt for int value, and we'll say enter the size square to print. So that becomes the string then. I don't need to do my own prompting. Okay, and then we're going to take all of this then, and we're going to cut that out to be its own method. So we'll say print square as a method given the size. So we need to write a new method here then. So public static. And now this is a void method. We don't need to return anything. It's just going to do something here. So we'll say print square given an int for size. We'll do this little loop-de-doop. Loop-de-doop. That's a technical term. Loop-de-doop. I'm pretty sure that's a technical term. Okay, that was that idea. Now we'll just say, okay, sure, you give me the size, and we'll print the square. And then rectangles. We have two different prompts here. So again, we're going to use this prompt for value. So, and what the prompt is then is enter the size rectangle. Now, sometimes those curly braces and things and parentheses get a little funny here, but the parentheses here for the method, prompt for int value, and inside of that is our quote. If it doesn't loop, it can't dedupe. I like it. So we get a length, and then we'll do the same thing for width. We'll do a prompt for value instead of this whole doing our own prompt and parsing it and all that fun stuff. And we'll give it then the prompt here. What is the string that we want it to print? Now we have a length and width here. So it's upset. Right now it says incompatible type. String cannot be converted to int. Oops, I lost my prompt for value. I think I must have done a cut instead of a copy. Goodness, sometimes those are fun. And then, sure, maybe we'll put this inside of our print rectangle. So I'm going to cut all of that out and say print rectangle, given a length and a width. So we'll make a new function. Remember, you can have more than one argument. So public static void, there's no return type. We'll have print rectangle. Oh, all right, got the mute there, good. Now, remember, when we're defining these parameters, we have to tell it what type it is. So an int for length and an int for width. When you give them as arguments here, you just say, okay, here's the length, here's the width. You don't need to tell Java that it's already an int, because it knows, hey, the int here is length, because you know you declared length as an int, so it fits. Give that little format. So there's our rectangle, right? Printing our rectangle out. That looks good. then we were going to have our triangle. So again, we have a prompt for int value here, given this old prompt here. We can get rid of that. And then we want a print rectangle, print right triangle. Print right triangle, given in the height here. This is going to be right triangle then. Right triangle. So we'll add another function, or another method here. Public static void print right triangle, given the int for, I forget what we called it, height or something. Yeah, it looks like height. Okay, so that's our method there. So again, we just have all of our prompts here. They work out. You can add in the spaces. The spaces don't really matter one way or the other. And we'll have else if shape equals ignore case equals ignore case. This was going to be our equilateral triangle. I'm just going to copy paste that because that's a big obnoxious thing to type. Here's equilateral triangle. And that's got to be in quotes, right? Equilateral triangle. My goodness, who came up with that? Okay, so now this one's a little trickier here because we wanted to have an odd size width for this, right? The idea was this was going to be an odd numbered width because we have 1, 3, 5, 7, right? As it gets bigger and bigger and bigger, it's just like the width of it, the number of stars at the last row. A couple of people just did number of rows, and that's perfectly fine. But we'll do the width because that's what I had in mind. So for this one, we can't just prompt for an int value, right? I guess we can, but we need some sort of additional loop here. So what we want to do here, we can make methods call methods. So we're going to write a new public static int prompt for odd number, given a string for the prompt. And to do that then, we're going to say, okay, int number is 0. And we'll say while number modulus 2 equals 0. Right? If you mod 2, that's the remainder. So any number divided by 2, if it evenly is divisible by 2, it's even. If there's a remainder, it's odd. So while number is even, let's prompt for an int value, given a prompt here. We'll say number equals, and we can then use this other method that we have, again, given the prompt here, and then when we're done, we'll return number. So our function, our method here, can call this other method. Right? This is just adding in that it's odd. It's saying, okay, as long as it's even, keep on asking. So we can prompt for an odd number here then. So we can say our int for width is going to be prompt for an odd number, enter an odd number for the base. How about base? How about that? I like base. For the base size. Sure. Okay, and then we will print equilateral triangle. Equilateral. It's going to be funny if that's spelled wrong anyway, but that's okay. Give it some base. So I need to go write that method. Okay, so we'll write another method. No big deal. Again, we're not really gaining a whole lot here aside from this functional decomposition. Equilateral triangle. We're taking a big problem and we're breaking it down into smaller and smaller and smaller steps. Right? Doing all this at once, it's a lot to do, but doing it one step at a time is not so bad. And now I can get rid of my scanner here. Look at that. Excuse me. Did I spell that wrong? I might have spelled it wrong. Equilateral? That's probably spelled wrong. Equilateral. How do I spell it here? Yeah, QI. Okay, yeah, I. So I'm going to right-click and do Refactor Rename. It's going to rename it everywhere. Because I don't want to... Oh, I can't. Equilateral. I'll just copy-paste then. That's weird. Okay. Now, how are we going to do this, right? We needed to find out how many spaces we needed, right? Or how many rows tall it was and how many stars we needed. So I'm going to say int stars equal 1. And I'm going to say int spaces. So the number of spaces then relates to how tall it is, right? If we like kind of sketch this out, a triangle with a base of 5 has 5 on the first row, 3 on the next row, 1 in the next row. So there's one space. I guess I can do this. We'll draw it here. Drawing's always fun. Maybe it'll draw. Oh, excuse me. Right, so if we have 1, 3, and then 5, here's a space, and here's 2 spaces. So this was base of 5. Here, if we had base and spaces, it had 2 spaces. If we were to add another one, right, with a base of 7, it had 3 spaces then on that first row. And we're going to see everyone goes up by 1 more. So 9 is 4, 11 is 5. So what can we do mathematically to figure out how many spaces we have given the number of stars in our base? Well, it turns out it's just divided by 2. And if we do integer division, we're going to lose that decimal remainder. So 5 divided by 2 is 2.5. Drop the half and you just have 2. 7 divided by 2, 3.5. 9 divided by 2, 4.5. 11 divided by 2, 5.5. So we can do some quick arithmetic and say my spaces then is my base divided by 2. And we want integer division here. So integer division here is good. That's what we want to have happen. Right? And then we're going to say while my stars is less than the base, or less than or equal to base, probably, we can do something. So you could do a for loop. I like the while loop. Really doesn't matter one way or the other here. So as long as we don't have the number of stars as our base, we need to print the spaces and then print the stars. We'll say for int star is 0. I'm sorry, space. Space is 0. Space is less than spaces. Space plus plus. So for the number of spaces, right, starting at 0 up till I hit the number of spaces I'm supposed to have, let's system out print. Now you want print, not print line. We'll print a space. And then we'll do the same for stars. So for int star equals 0, star is less than stars, star plus plus. Nope, star plus plus. Let's print out a star. And that's a print, not a print line. Right? Once we've done both of those, then I can print a line to go down the next line. I want all my spaces and the stars to be on the same line. Then I'm going to take my stars plus equal 2. Right? Let's add 2 stars, and we'll take our spaces minus 1. Right? Take away 1 space, add 2 stars. We'll do this when stars equals the base, and then we're all done. Should we give it a try? Let's give it a try. I'm going to copy paste equilateral triangle because I'm terrible at this. So I'm just going to paste that in. Okay, how about we do 22? It's an odd number. How about 23? Oh, it didn't do anything. Okay, hang on. Let's build. Did I actually call the method? I think I did, right? Yeah, I did. Print equilateral triangle. Print equilateral triangle. Okay, it should do it. Try one more time. That, or you can just do that compile and save thing. Both of those ought to work. Hate that setting. Equilateral triangle, 23. Right? 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23. 23 stars. We get a nice little equilateral triangle. I mean, I guess it's not exactly equilateral. We're just kind of making it up as we go. But essentially, I mean, given the right formatting, I guess. That's not a right triangle, at least. Okay, so now we have methods. So the only part that's in main here then is, okay, get the shape, and then if it's a shape, get the integer values, and then call the print. That's it. That's all main is, so it all fits. Does that make sense, what we were doing with the lab here for lab 5? Oh, excuse me. All right, let me commit this one to GitHub here. And then we'll look at the project. Now, I think we had even started project 1 stub, right, with just a bunch of empty methods, right, just to give you some ideas of what we could do with methods, I want to say. Let's take a peek. 1500, winter for Tuesdays. Yep, here's lab 5. We'll commit and push. All right, cool. Thanks, Lemon. I like when you guys talk in chat. I don't know. I get real bored just hearing myself talk. It's always fun when you folks are hanging out. Let's go open that one up. We'll close all the other projects, and then we'll go open that project 1, and we'll go finish it out here. Yeah, there we go. Project 2. I'm sorry, project 2. Project 2. I know the numbers. So let's go back to our assignments. I don't think I made any changes. We can discard that. And let's go check out project 2. So less people finished this one than the previous one. That's a little concerning. If you're getting stuck on something, reach out and let me know. I'm happy to get you folks unstuck. I'm not going to tell you to go away. All right, so our terrible tribute to Zork, right? Our bad text-based adventure game. Whatever our story is, right? The game loops until the end of the escape word. We'll have help that will tell them all the things they can do. We'll have different movements and different actions. Every time they go a direction, it reduces their energy by 1. If they have no energy, don't allow them to go in any direction. They have to sleep. Sleep action to restore their energy. If they enter a command we don't recognize, tell them we can't do that. Keep track of the number of turns it takes. Once they escape, tell them it took so many turns. And everything just repeats every time. So, project 2. Right, we kind of broke this into our different methods here. So, display intro story. Display intro story. Sure. Welcome to our terrible game. You wake up in the woods. Don't remember anything. Your Super Bowl party went wrong or something. Who knows? Excuse me. Okay. Asks the user what they want to do. So, ask the user what they want to do. What do you want to do? And then we need a scanner. Oops, sorry. Did we make a scanner? So if you want, you can make scanner at this class level static thing too. I'm not a fan of that, but it's okay. So I'll just do it in here. We'll say scanner, we'll call it keyboard equals a new scanner, given system.in, and then we'll return keyboard.nextLine. Okay, whatever they want to do, we'll just pass it back. Capital S scanner, there we go, and now we should be able to add our imports here. Yes, you should. You're like a dungeon master for an unknown player, exactly. Someone else is going to come and play our game and have a lot of fun with it for sure. I believe they refer to this as railroading though, and like the only thing you can do is these 4 actions. All right, cool. So ask the user what they want to do. Great, we have an action. We have number of turns. Well, it doesn't equal some escape word. How about like, get me out of here? I don't know, sure. We'll do the action, and then we'll ask what they want to do. Okay, sure. We'll do the action. If it's help, we'll display help. Else if it's sleep, we'll set the energy. Else, well, we need to do more things here, right? This one obviously wasn't done yet. So how about else if we say my energy equals 0. Double equals, right? If it equals 0, really that's if it's 0 and we wanted to do a specific thing here. Ooh, you could let them eat a candy bar to regain an energy. There we go. Sugar them up, right? Definitely. Just sugar is like pure energy for us. Maybe I should be trying that. Although the sugar is not good for my diabetes. So this one maybe we want to put in here. Maybe we want to wait on that. So how about we do the display help first? We'll come back to this. So what options are valid? So you can, well, how about go north, go south, or go east, go south, go west, jump, sleep, run, maybe not run. How about jump, hide, and I don't remember. We came up with another silly one up here, right? Sleep, eat, jump, hide. Oh, eat. That's right, eat. 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 Okay, so that's the help. Those are things they're allowed to do. Okay, so if the energy is 0, maybe and the action.equals ignore case. Now this one's gonna be a little bit obnoxious, but that's probably okay. And we can either check for it here, or we can check for it in each individual action. Maybe in each individual action is probably better. How about that? Let's go that way. So let's forget that. We'll say, okay, hey, if their action is equal to go north, then we'll tell them they're going to go north. So this one is just an else, right? If it's not any of the above, we'll tell them you can't do that right now. So if it's north, you go north into the forest. Sure. Else if, how about it's, we'll just put a couple of these. There's east, there's south, there's west. go east, go south, go west. And then if you go north, then we'll take our energy -1. And we can only do this if our energy then, if energy is greater than 0, then you can do this thing. Otherwise, we'll have to tell them, right, in our else block here, we'll have to tell them, you are too tired to do that. You need to sleep. Sure, why not? Okay, so this is probably even better then. We'll copy this one and forget all of these ones, because we'll do this, it's the same operation. Boom, boom, boom. Okay, so go north, go east, you go east into the, I don't know, what do we go east into? Into the mountains. You're too tired to do that, you need to sleep. Now this is feeling really obnoxious, right? This having to do this every single time. There are better ways, and we'll look at that in just a minute here, right? Because anytime you have the same code more than once, you should feel bad about yourself, right? So, okay, can we fix this? Okay, sure, we can fix this. So how about we take this message here then, and we say, instead of if energy is greater than 0, we'll say if has enough energy. Energy. And that will return a value of either true or false. And then we can write a method here, like public static boolean has enough energy. And what we can say, if energy is greater than 0, return true. Return true. Otherwise, we're going to spit out this message here and return false. Right? We can say, okay, if you have enough energy, true. Good, we got a true result. And then in our method here, we can just say, hey, if you have enough energy, you do the thing and you lose an energy. If not, we're already printing out that message down here when we check to see if you have enough energy. Just kind of a fun little shortcut. And just that way we don't have the same code twice, right? So then I can take each one of these then, and this can be a little bit cleaner. Go east then, it's east into the mountains. Because we don't want to feel bad about ourselves, right? We want to feel good about ourselves. We go south into the lake. Sure, why not? Oops, sorry, we need to replace that one. South into the lake. And then, oh, we had north, north, east, south. Oh, this should have been west. Oops. One of these should have been west. Let me move this one here. I like them in order. I don't know. They don't really have to be in order, but it makes me happy if they're in order. Go west, west into the plains. How about that? Okay, so now we have our 4 action commands. Go north, go east, go south, go west. And we're making sure that if they don't have energy, they can't go that direction until they need to sleep. Okay, and now we'll get sleep, eat, jump, and hide. Okay, well, we already had sleep. Sleep was done, and then we'll say you sleep and wake up feeling energized. Right, give them some sort of message here. Why not? Okay, so sleep was done, and then how about we do the rest of them over here? So if it's not sleep, what do we say? We could, oh goodness, that would have been too long again. Jump, sleep, hide, and eat. So we need one for jump. You jump and land on your ankle funny. Ow. Sure, why not? Hide. You hide from your shadow. And then eat. Eat. You eat some stale biscuits. I don't know. Rations, why not? Okay, and if it's not any of those, then is it go north, does it go south, does it go east, go west? Oh, our go north we didn't fix. Oh my goodness, that's what it was. You go north into the forest. See, I didn't clean up the right one. That was my mistake. That's our north. And then each of these, they could be, like this is the do action method here. Your eat says east, really? Oh my goodness, yep, eat, thank you. Yeah, so jump, hide, eat, sleep. Those are our actions here. We can do those things. We could turn these into methods. I mean, they're one-liners, so it's not too concerned here. They're like go north, maybe could be its own. You know, it's okay. We've got lots of options. Or like it could have this is a travel command. I don't know. We got lots of different ways you could break up. So there's not necessarily any wrong ways of breaking things up with methods. Whatever's going to make sense to you to break up a big problem and make it smaller and smaller and smaller. Right? That's the idea. We're doing this functional decomposition, one of my favorite technical terms here, and breaking it apart. And here's our story. We're not tracking the number of terms. I'm sorry, our number of turns. So that also probably should be a static value. Its number of turns is 1. And then we're going to go increase that. So this number of turns is going to go up every time except for help and except for you can't do that right now. So what I think is probably easiest then is every time we do an action, I'm going to say plus plus. And then I'm going to cheat and say, okay, if it was help, let's take that down by 1. And if it was you can't do that, let's take it down by 1. This way I don't have to add it to every single valid action. I just say, okay, these two don't count, so we'll take that away. Again, just a way to cheat it. Not a big deal one way or the other. And then you took number of turns to get out. We had that part already done. So let's see, do we hit all the things here in the rubric? We have 4 direction commands, we have 4 action commands. We have the sleep command restores energy. You can't use a direction command if energy is 0. You track the number of turns they spent at the game, only valid actions. The help command displays a list of valid commands. Game runs until they enter the escape word. I think so. I'm feeling a little loopy, folks, I'm sorry. So let's fix that compile on save nonsense. Let's run our game. See if it works. Swamp. Oh, I'm sorry, I missed swamp. Where was that? Where did you want to go into the swamp? What would you like to do? We want to help. Okay, you can go north, go south. How about we jump? You jump, land on your ankle. Can we sleep? We sleep. Okay. Can we eat? No, east. Can we eat? Okay, we ate some stale biscuits. Can we hide? Hide from our shadow. How about go north? How about go east? How about go south? How about go west? How about go north? Go north. Go north. I'm trying to run out of energy here. Go north. Go north. Go north. Go north. Oh, now we're too tired. We need to sleep. Okay, so sleep. Now go north. Now get me out of here. Look at that. It took 18 turns to get out. That's it. So maybe this actually should start at 0. It probably should start at 0 because the first to do action adds 1 to it. So it would be our first action. And not too concerned if you're off by 1 there. That's no big deal. Okay, thoughts, questions, concerns? Sound okay for project 2? I'll commit this one to GitHub here. So project 2, get that one added. All right, do you want to do the midterm review stuff, or do you want to do the new classes stuff first? Which one sounds like more fun? You have a vote? Or we can take a break? Classes first? Okay. All right, we'll start talking about classes first. Do you want a break now, or just keep going for a little while, and then we'll kind of break in the middle of classes? Up to you, folks. And drink some more fluids. Oh, it's getting warm up here. All right, keep going. You got it. We'll keep going then. All right. So we keep adding tools to our toolkit here. We added this method tool, which really didn't make us didn't allow us to do anything we couldn't do before, but it saved us some time, energy, and effort. And it's basically the same idea with classes. It's a fundamental of object-oriented programming, and we like using them because it makes life easier for us. It doesn't mean we couldn't do it without it, but it's a foundational tool that we're going to use here. So this is, what was that, Chapter 7, Classes? think it's chapter 7, right? That's what I had. You can look here again and see. I think that was in our syllabus link, right? Ooh, a little funny. That cold medicine is good stuff, my friends. Good stuff. All right. Yeah, chapter 7. Okay, good. Yeah, we're kind of skipping 6 because we've kind of already talked about debugging stuff, so I'm not too worried there. And then don't forget for quizzes now, we should have 1, 2, 3, 4, and 5. So 5 is due tonight, and then I'll open up the quiz for chapter 7. It'll be due next week by 11:59 p.m. You can start the midterm, but you've got all week on it, so I'll have it in and scored and everything before you actually have to submit the midterm or anything, so you should be fine there. Okay? All right. So one of the idea with classes, right, is that it's a normal way for us to talk about things in code. And the idea with classes is that they represent generally a noun. It's some sort of object. And you folks are very familiar with the fact that this is a can, but there's different types of cans, right? There's different instances of cans. You can have a can of LaCroix that had orange flavor in it. You could have a can of Coke Zero, right, that had Coke Zero in it. You had a red can and a gold can, right? You might have, do I have any other interesting cans? A Perrier can with a different size, right? Each can has a different size. So this one here is 250 milliliters there, where this one here is, how many milliliters? 355 milliliters. It's somewhere over there. Oh, that one's kind of shiny. Sorry, I don't know. You probably can't see that one. That's okay. Right over there somewhere. Number of milliliters. It's too shiny. Okay, never mind. But you get that idea, right? That, there's a can, and then the can have different attributes. So it's not quite generics yet, Root Guy. No, not quite. We don't really get to that this much this class, but later on we do. So we've actually used some classes before, but we're going to go write our own class here, and we're going to call it can. So again, generally they'll be nouns, and for all of our purposes they're going to be nouns. Later on you can get to some more advanced stuff where they're not necessarily nouns, but generally it's going to be a noun for a class, and it's a separate Java file. One of the rules of Java is that each Java class has to have its own Java file. Now, I just right-clicked on my package over here, so I did that really quick. You probably haven't done that before. You come to your project, you open up this package section, you go to New Java Class, and you give it a name here. That's what I did for can. Now, you notice this one doesn't have a main method. Public static void main string, square braces, args. We don't have that. Classes generally don't have main methods. Now, I know that we've been using this and it says class up here, and that's fine. We're not really using it as a class, so I don't really count this one here. What we're going to do here is, this is our way that we're going to represent can. So a lot of times you might think of a class as like a blueprint. We're going to say, this is going to define how you would make a can, and then I'm going to let someone else go and make as many cans as they want using my blueprint. What that means is we're going to do a couple of these cool things. So some of the fundamentals of object-oriented programming are encapsulation and abstraction. Now, those sound like really fancy terms, but I promise they're not so bad here. So one of the cool things about abstraction is we can do this thing like scanner keyboard equals a new scanner, given system.in, and then I can say keyboard.nextLine. Keyboard, I can't spell anything today. Add our import for scanner, and maybe we'll have like a string for name is the keyboard next line, and we'll ask them your name here. So scanner is actually a class. We're making an instance of it. We're creating one using that scanner blueprint. Ours happens to use the system in standard input. And then I can use my class here called keyboard. I can use that instance that I have, and I can do this thing called next line. Now, you and I don't have to know how next line works. We don't have to know anything about what happens behind the scenes to get input when the user types at the console. Right? We don't really care, actually. We just know if you call next line, you get back a string. We're dealing with this in an abstract manner because scanner gives us this, what we'll call a application programming interface or an API, all the things that you can do. When you say keyboard dot, these are all the things you can do with Scanner. Next, all sorts of fun things here. We basically only ever use next line because that's the best one here, right? But all of those things will do what they're supposed to do, and we don't need to know how. So we get to deal with them in this abstract manner that says, okay, there's a class that lets you get input from the console. Let's just go do it. So we're using it in this abstract manner that we don't know how it works, so we don't really care. But one of the nice things that happens behind the scenes, Scanner has encapsulated all the details about itself, all of its inner workings, into one nice little package for us. Right? So Scanner is one nice little portable package. It's taken all the things that have to happen for you to get input from the console and put it into one little package for us. We've encapsulated all those details. And what we get then, what we get to use is that application programming interface, the public interface that says, okay, here's the things you can do. So encapsulation and abstraction tend to go hand in hand when we think about how we define them. So we think about CAN, right? CAN will have a bunch of details that we want to take all of the things about CAN and encapsulate them into one nice little CAN package, one CAN class, right? We're writing the blueprint for it. So what are things about CAN? What are attributes of CAN? Well, things that we know about CAN, we said there was an int for, how about the size in milliliters? Now, I'm a little bit particular about this. So if you just said size is very confusing, right? You have no idea how you want to measure size. So anytime you're dealing with something with units, I would always encourage you to put the units in the name. So that's size in milliliters, right? That's the size of the can here. Okay, so we have the size of the can. We have a string for, how about the beverage? Beverage in can? I don't know, just beverage. It's like, so you might have Coke Zero, you might have LaCroix, you might have Perrier, you might have, what else do I have? I have way too many cans around my desk here. Some other things. Hey, thanks so much for following along. A material, are they really made out of tin? I thought they were aluminum. Aren't they aluminum cans? Yeah, we could have different materials, I guess, if you wanted to specify. LaCroix flavor is static, yeah. You know, it's got the essence, right? That's all you're looking for. That's all you're looking for. Someone once told a joke, was it like silly LaCroix flavors was like the water truck drove by a fruit truck or something, drove past an orange truck, or drove by an orange grove, and that's your flavor. So that's okay. I don't mind. I'll actually drink just plain sparkling water, just like plain Perrier with no flavor. We got hooked on that when we spent a couple weeks in Ukraine years ago. So it's a lot of fun and much more interesting than regular water, to be sure. Regular water is just kind of boring and bland, you know. I'll put my cans over there where you can't see. Oh, okay. So can then has a size in milliliters. It has a beverage, the type that it is. Now it probably also knows like how much liquid is currently in it, right? How about liquid or contents? I don't know. Yeah, you might have an ID. Maybe if we wanted to specify for can, I think beverage is probably fine enough. We got options, but we want to say like how much is currently in it. So how about current volume? How about that? Current volume in milliliters. Right? So we'll have the size, and maybe size then is the max volume. Might be more specific. How about maximum volume in milliliters versus the current volume in milliliters? I like those. The more specific you can be, the better. Right? I love long variable names. Some people don't, but that's okay. So say, okay, these are the things that you can do with can, that can knows about itself. So the idea is every different can that there is now will have its own set of these attributes. So I can make 10 different cans, and they each have one. Oh, GUIDs, yeah, don't get me started on GUIDs right now, root guy. Okay, so right now I don't really have a good way of making cans, because if over here in my code here, then I can say here, so like scanner is the type here, keyboard is what we're gonna call it. So I can say can, how about this is Coke? we'd say equals new can. Now right off the bat we can do that. So can is the type, and then new is the keyword that makes a new instance of this in memory. And then we say new can parentheses. So this is doing something called calling a constructor. We'll look at that in a little while. We got lots of things to talk about for classes. But then if I say coke dot, there's really not anything we can do with it here. There's a couple things. We have all these attributes, like coke.beverage, right? Sure, we've got all these attributes here. We see a couple attributes, but then there's a couple other things. Don't worry about it. This will make sense once we cover the next chapter why these other things show up here. But if I wanted to say beverage, right, equals Coke, we're going to set it to Coke. Coke dot maximum volume in milliliters. What do we say? That was 300 and, oh my goodness, where is it? 355. 355, and Coke dot current volume in milliliters, it's empty. We'll set to 0. So I can set a bunch of properties, right? And then I can print these things out. So I could say, let me print the can of plus, oops, Coke dot beverage. Sure, let's see if that'll run for me. Enter your name. Oh, that's right. We had that whole line here. Compile and save. Killing me. One more time. Let's run it. It is my best friend. Definitely my best friend. When it works, it's great. It just doesn't work most of the time. Can of Coke. So, sure. So we got those values. I'm going to just get rid of that because we don't need those here. Or what we could do then, how about we do this? We say, hey, let's the kind of beverage. And then we'll have a string for beverage is the keyboard.next line. Next line. And I can set it equal to beverage here. Now I'm going to put this in debug mode here. So I'm going to put a breakpoint in, and we're going to go and debug our program. Right, so we can actually see what's happening behind the scenes. It's really fun. So it's got to load a second here. We'll get to where it's about to run that line, and then it'll pause for us. Just thinking about it, right? Oh, nope, it's waiting for me to type something. Enter the kind of beverage, sorry. It's not, it didn't wait to hit a breakpoint, so let's say Coke. Now it hits this line, right? It was waiting at this keyboard next line, and I was just sitting around twiddling my thumbs. So right now, we have a beverage as a string here, but if I go step here, now I'm going to see, hey, I have this can, so the type here is can. I'm calling it Coke in my variable name, but I can open it up and I can see the contents here. So I'll see my ints are 0, which we're going to talk about in a little while. They start off at zeros, and then beverage as a string gets this weird thing that says null. Null is really dangerous, and we're going to talk about how to fix that in a little bit. But we can say, okay, beverage is beverage here, can.beverage. Now we'll see my Coke's beverage attribute. Let's think about it. Coke beverage attribute. Maybe. Come on, compiler. I'll try and run another one. There it goes. Beverage here is Coke. We can see now the max volume is 355. Right, so we can see we're setting the attributes here. Now what we've actually done here, though, is considered bad form. We have gone in and we're letting people access these values directly. This is a problem because we're not following good practices for encapsulation. The idea with encapsulation is we want to take all of the details and we want to package them up so you can't get at them except from our public interface, our API. So to do that, we're going to add some keywords here. So I'm going to say this is a private int. So I'm going to list all of these as type of private int. And now when I come over to my code here, they all highlight in red. They say beverage has private access in can. You can't access the beverage attribute outside of the class. And you might think, well, how is that helpful? And we'll talk about that. Don't worry, it is helpful. So what we need to do then is we need to give you public methods to call to get these values or set these values. So turns out this is super common to have get and set values, like a way that you can get the value and a way that you can set the value, that it's built into NetBeans, right? There's a shortcut for it. So we'll do it the hard way once, I think, and then after that I hate typing and I won't do it. So what we want to do here then is add a method here. So I want a public method. So if it's public, it's part of my application programming interface. It's part of that API, part of all the things that CAN says it can do when you ask, what can you do? So I'm going to write a public method here. Now we're going to get rid of that word static. So remember in project 2, like everything here was static. When we're talking about classes, we're going to now move away from static things and say, hey, these are regular methods. And what that means is they will have access to these attributes. So each CAN will have access to its own set of attributes here. Static means it only exists one time. Again, we'll talk more about that. Don't worry too much. We'll get there in a little while. But I'm going to write a method, so public string called getBeverage. And what it's going to do then, it's going to return the beverage attribute. So if you want to get my current beverage attribute, you call the getBeverage method. So it's can.getBeverage. Coke.getBeverage here. We'll get the beverage attribute. Now to set values, we're going to write set methods. So set methods are generally void methods. We're going to say set beverage. And then we need an argument. You need to tell me what the beverage is you're trying to set. We'll say beverage here. So if you tell me what beverage I want to set, I can now set my beverage. So I say beverage equals beverage. And if you notice here, they're both orange. And it gives me a little warning here saying the assigned value is never used. So this beverage up here is green. This beverage here is orange. So a weird thing has happened. There's this idea of scope for variables. So the scope of this variable is to the entire class here. Like everything inside of this set of curly braces has access to beverage. Is this green, we'll call this an instance attribute, right? Every instance of CAN will have its own beverage. So I can have 10 different Cokes if I wanted. I can have some Coke Zeros, I can have some Sprites, right? I can have Perriers. They can each have their own beverage. Beverage here is the argument that was given, or the parameter that we've defined here. So if I want to access the instance variable, I say this dot. This means this current instance. So this means the current instance that's being used. We'll set this beverage to the beverage argument here. It sounds a little funny. Don't worry, we'll get used to it. So this dot means my class level attribute, my instance attribute here that's defined in the class. So we can do get and we can do set. So now I can say, instead of beverage here, I can say Coke.setBeverage given beverage. And then we'll go set the value here. Right, and I can run this one now. And it'll say, okay, what kind of beverage? We'll set it here. So can of Coke, we get a can of Coke. So I can call the set method. This is the public method here. So we're writing public methods that give people access to our private attributes. Again, seems a little silly. We'll get to that in just a minute, don't worry. Now the next thing, right, typing this all out by hand is really obnoxious. So if you right click, there's a really cool option here called insert code. This is one of my favorite things that NetBeans does. You can say insert code, you can say getter and setter. It says, oh, which one do you want to add? I'm just going to check the box for everything here. And look at this, it writes it for you. Get max volume in milliliters, set max volume in milliliters. Given a max volume in milliliters argument, sets the this dot attribute. Get current volume, set current volume. This is just a common convention here in Java, in a lot of programming languages, to have these get and set methods. Sometimes they're called accessor methods when you access them, you get them, or mutator when you set them. I like sets and gets because that's easier to say. A little easier on the tongue there. Get and set methods. So now, if I want to, I can set any of these attributes here. We'll say Coke.set maximum value. Set maximum value, maximum volume in milliliters, given the 355. And how about set current volume? Nope, set current volume. There we go. Given 0. So we're writing methods then that work on this given instance here of CAN. Okay? And then what's cool is I can make more instances of CAN. So this can be Coke 0 equals a new CAN. And then with the Coke 0, I can say set beverage to Coke 0. And then I'm just going to copy paste this line here and feel bad about myself, but that's okay. Now it's not Coke.getBeverage, it's Coke0.getBeverage. And I'll see I've got two different cans now. So each can, anytime you use this new keyword, it's making a new instance of that class in memory. And it's telling Java, hey, I want to go store one of these things out in memory. I need room to store 2 integers and a string. And Java will ask the operating system for room to store 2 integers and a string, and then you can access it through the variable here, Coke. So Coke is an instance of can. So now I have one instance of can in memory. This one makes another instance of can in memory. And they each have their own distinct set of attributes. Okay? Now the next best thing here, so why these set methods are important here, is we can do sanity checking, right? If you try and say, hey, set the maximum volume in milliliters, I can do some checking. I can say, hey, if my maximum volume in milliliters is less than 0, don't do it, right? So I'm just going to say, okay, it's 0 now. Otherwise, let's go for it. So this lets me protect my class here. So you can't give me a value. Oops, sorry, this dot. Oops, this dot. You can't give me a value that violates my class, right? My class for can here is going to obey the laws of physics, and you cannot have a negative volume, right? That's just not possible. You can't have a negative volume here. So if you try and give me a negative volume, I'm just not going to accept it. I'm going to say, oh, it must be 0. And 0 is probably wrong too. Like, I guess you could, if it was a solid can, you could have no volume, right? So I guess that's fair. That obeys the laws of physics. And we'll do the same for set current volume. I'm going to say, hey, oops, inside of here, if my current volume in milliliters is less than 0, we'll say this dot current volume in milliliters is 0. Now, what I also want to do here, I also want to check, right? I can say, this would be my else here, right? Sorry. Give that a little format. So if you try and give me negative, just stop at 0. Nope, we just have no volume. We can't have a negative volume. Otherwise, sure, I'll take it. But now we want another check here. We want to say, okay, hey, if the current volume in milliliters is greater than the max volume in milliliters, what do we want to do? Well, if you say, okay, hey, your current volume should be more than the max. Oh my goodness, that's way too many of these things here. That's the wrong, okay. Goodness, goodness, goodness gracious. Too many parentheses here. I'm sorry, too many curly braces here. I'm going crazy. As I start lighting up red, I just start getting rid of them here. So the first one says, okay, if it's less than 0, no, that's invalid. No, you can't do that. If you try to set it to more than the max, then I'm going to say, okay, that's no good either. This current, we'll just set to the max. Like, hey, you tried to pour, that's how many ounces is this? This is 500 milliliters, right? Yep. 500 milliliters into a 355 milliliter can. What's going to happen? Well, this will stop filling once it hits 355 milliliters. The rest is going onto my lap. Bad news for me. Okay, but we're protecting our class. We're making sure that our instance of can obeys the laws that we're set for it. You know, we're saying you can't have more than the max volume, right? Makes sense. And you can't have less than 0 of anything. So when you have these public methods here, you're able to do this sort of defensive coding, I guess is one term for it. We're making sure that the arguments you give me are valid. If we don't have a set method, if I just gave you access to current volume in milliliters like we had when we first started, there's no way to do any of that checking. When you say, hey, current volume equals something, it just happens. So the reason why we want public methods to kind of wrap around these private attributes is we get a chance to ensure that you don't put our class, our instance of a class, into a bad state. Because if you have a negative volume, probably bad things are going to happen. I don't know what, but weird things could happen. So that's the reason why we have public methods, especially the set methods here. The get methods, not as interesting, but once this value is marked as private, the only way you can get access to it is through a public method. So I can't say, hey, you can get it publicly, but you can't set it privately. Java is not as cool as C#. Okay, so that's the basic start of a class here. Again, there's a ton more we need to talk about. But then the other thing now this lets me do is I can talk about and use an instance of can. So I can write another method here, like public static void. Now, again, back in this class that has main, everything's static. because main is static. In the classes here, they're not static because we want access to these instance attributes. We'll talk more about it later. Don't worry too much about it now, but like anything in the class that has main will be static. Anything that's not is not. We'll call this, how about print can? Given a can, I'm going to call can. So you can give me a can argument. I'm going to call can here, and I can print out that can of whatever. And then it's can.getBeverage. So now I don't have to have the same code here, right? I can call print can, given my Coke, and I can call print can, given the Coke 0. So I can take one variable here, and I can pass it to different arguments or different functions, different methods here to act on it. So I group all of these things together, which is what programmers like, because all of these things kind of belong together. They all belong to a noun can. I don't want to have to pass around 3 different arguments every time. Pass around a beverage argument or a beverage name argument and a max volume argument and a current volume argument every time I want to do something with can. Right? It lets me group all of these things together into what's sort of like a natural language thing, right? When I talk about cans, you know what cans are. In fact, I talk about chairs. You know what a chair is, but you know that my office chair might have a certain number of wheels, or might have a certain fabric, or might have the ability to go up and down, or might have the ability to tilt, these sorts of things, and other chairs might not. Right? Each chair gets its own set of attributes. Anything that we want to write here, anything we want to list, every instance of that class, right, when we use this blueprint to build a new one, will have its own set. So we can make them all different. We can keep them and use them in memory then, and I can have a bunch of cans. Right? So when I run this now, we'll get the same output here, which is our can of whatever the beverage is here. So beverage was Coke, we get a can of Coke, and we get our can of Coke 0. So you can take the classes and you can pass them around here as arguments, which is super cool. So not only can you just have like integer values or strings that were passed around, you can pass around whole classes or instances of classes here. Okay, I think we're due for a break. It's 7:08 here, so why don't we take 10? We'll go take a break. Let me get some more fluids. Feeling real loopy here. And we'll do a little bit more on classes, and then we'll talk about some midterm prep, and we'll talk about the next lab, and we'll go from there, okay? All right, we'll put some music on. Let me start that at the beginning here. That's a good track. So we'll come back in 10 minutes, okay? That puts us out to 7:19, looks like. 7:19. See you folks in a little bit. Alrighty, folks, welcome on back. I feel like that went by really quick, but that's okay. That was, I think that was 10 minutes, if you believe the clock. So we're probably good there. So we're going to wrap up classes here. So we're not going to hit everything super deep. We're going to pick this topic up more when we come back, or if you come back in object-oriented programming in Java. Java 2 or 2151 is the course number. So we'll pick this up more there. So there's a lot in the chapter. It's all good stuff there, but we're going to focus on instances of classes here. We're not going to get into that static stuff too much here or there. I don't think. Let me double check. This is why it's all written down, right? So we can always double check and make sure. Maybe we will. I'm forgetting, folks. My brain's like mush today. I'm sorry. This one here. Yep. So we use our IDE to develop the program, use the debugger, use constants, variables, primitives, data types, related operators, type conversions, basic input and output. We'll get to the input and output. To follow Java code with if, else, switch, while loops. Write Java code to read to and write from disk files. This one's a lot of fun. We'll get there. Write Java classes, create objects of that class with private data members, public accessor and mutator methods, and a constructor. Understand the concept of the scope of variables within the object and its methods. Great. We'll talk about core concepts of inheritance, utilizing arrays, and a basic GUI program with event handling. Okay, yes, we don't need to get into the static stuff. We do that in next class. So don't worry too much about it. Like, it's there. It's a good topic. But I'm not going to ask you to do it in any of the projects, okay? If that's all right. Man, I feel like a raisin. Can't get enough fluids here. Okay, so those were the main outcomes that we're looking for here. All right, so we have our class for can, right? We have get methods, we have set methods. Now the other thing we want to do, right, you'll notice we can say can, and if we just give it a set of parentheses. Now, what's fun here, I'm going to put a breakpoint here, and I'm going to run this again in debug mode, and we're going to watch. So with debug mode, you can actually jump into methods, which is super cool. Excuse me. So let's go enter the kind of beverage. That was Coke. Okay, now we're at this line. So if I do step into instead of step over, it's going to go into the method. So it's okay, here we're here in can. Let's step. And oops, oh, now we're in the class object. Sure, that's fun. This is, don't worry too much about that. We'll step into, and that was it. Not a whole lot was going on with can that we could see. But now we see the Coke instance here. My Coke variable has 0, 0, and null. Where did the 0, 0, and null come from? Those were defaults. But now on set beverage, if I could step, now it's actually going to go to the can class, right to the set beverage method. And all my attributes change, all my variables change. Now the only thing I see is this, right? This is the current instance. It's max volume 0, current volume 0, beverage is null. And I see the beverage argument here is value of Coke. I can step and I can see it actually changes the value here in this. So this being this instance. In this case, this is whatever's on the left of dot. So Coke is the this in this case. Sorry, that's too many words, too many times using the word this. But whatever's on the left is what the this is. It's the Coke's instance of that. And I can do that for each of these methods. I can step into and I can see, I go into these checks here. I can say, okay, hey, is it less than 0? No, okay, I'm going to take the max volume. Perfect. I can set current volume. Let's step into. Now I'm at current volume. Okay, well, what is this is max volume? Well, this is max volume of 355. Current's still 0, so sure, we're just going to leave it at 0. No problem, we set it to 0. So you can actually step in and see, just like you can step into your own methods, you can step into the classes methods here. But we still didn't see what happens here with this can set of parentheses. So what Java does for you, because it is super handy, is it writes something which is called a constructor for you. It's a default constructor. So a default constructor sets all of your attributes to defaults. So the default for anything that's a integer, or anything that's a numeric type, is 0. Anything that is a reference type, anything with a capital letter, is null. And nulls are really bad and dangerous. We don't want nulls. They can cause all sorts of trouble. So what we're going to do is we're going to write our own constructor. Now, constructors are special methods. Constructors, now, again, generally we want them to be public, but don't worry too much about a private constructor. We'll say public, and then the name here matches the name of the class. Now, there is no return type. So constructors are special and don't have a return type. And the name method matches the name of the class. Right? All of our other methods, you see, have been lowercase, right, with the follow our regular naming convention. Lowercase and then uppercase. So now we just say public can, and a set of parentheses. So this is writing our own default constructor. So we're going to set some values here. The role of a constructor, the purpose of a constructor is to give values to your attributes. And you want to give it good values. So max was 0, sure, current is 0, and then better than null, you want to say beverage equals probably an empty string. You want something that is not null. So a better default than null. Because what's going to happen here, so if I make a can, right, and I call can.getBeverage, right, and let's do that one more can. So I'll have a can, here's my Diet Coke, which is not as good as Coke 0. Coke equals a new can. And then I want to say print can given the Diet Coke. Before I actually go and set a value here. Sorry, let me undo this here. So let me comment that out real quick. So before I have any of these, remember, what we were getting was null. Okay? Let me close object out here. So if I make a can, that value is going to be null here, and I go up and print it, it's going to be really ugly. We'll get, okay, here was Coke, and we had can of Diet Coke, a can of null. Well, what is null? Null's no good, right? You don't want that. So a better than null here, right, is giving it a value like just an empty string. Now if I run it here with that empty string, we're just going to get can of, and it's going to be blank because there's just a blank string. We haven't set it yet. You have Coke, Coke 0, but it's not null. So again, nulls are likely to crash your program too. So if we comment this out one more time, and I were to do something with that here, that beverage. So if I said like, if Diet Coke dot get beverage dot equals ignoring case, if it equals Coke 0. If it does, print out yum, something silly. Right, and we run this. So this is with the default constructor that Java gives us here, where it's going to be null. And I say Coke, we get, exception, null pointer exception. Cannot invoke string equals because the return value, get beverage, is null. You got back null. There is nothing there. So null is even worse than empty. It's non-existent, and it will crash your program if you try and do things with null. So definitely bad here, but better than if we have a constructor. So we write our own default constructor, which I'm always going to say is a good thing to do. Even if it does the exact same thing as the Java provided one, I think it's always a good practice to write your own constructors here. Now when we run this, we're going to say, okay, Diet Coke, if it equals Coke 0, print yum. It does not equal Coke 0 because an empty string does not equal Coke 0. So we don't print yum. But now we don't crash. So with our constructor, we don't get null and it doesn't crash. This is really good, right? So we want to do constructors. Now it's a little bit obnoxious to have to write these all the time yourself, right? And yeah, sure, it is. So let me just comment that out for a second here. And turns out NetBeans knows how to do it for you. Insert code, you might have seen that one of these options was constructor. Now constructor gives us a checkbox here. We'll get to that in a second. I can just say generate, and I get, okay, here's the initial method here. Okay, didn't really gain me a whole lot, but that's okay. So sure, we have the form of it here. Right, so you can start by inserting code yourself, and to get some of these, at least start it if you forget, those return types or not having return types or don't want to type the name of your class, that sort of thing. The other thing we can do now, right? So remember how like methods can take arguments? You can have a constructor that takes arguments. So I can say, hey, I want a constructor that accepts arguments for all of these things here. And say, okay, you make a can. If you give me the max volume, the current volume, and the beverage, I will set all of these here. Now again, I don't actually like this here because I want to use my set methods that do the sanity checking. So I'm going to call set max volume in milliliters, given the max volume in milliliters. Right? I want to use my set method here because my set method has all the logic in it. We'll call set current volume in milliliters, given the current volume in milliliters, argument provided. And then, set beverage isn't really gaining me anything, but that's okay. We'll call set beverage, given the beverage. Okay? Don't worry about this overridable thing, no big deal. Now, you'll notice what's funny here, we have two methods with the same name. They're both called can. But one has no arguments and one has arguments. So this is called an overload. So an overload is a method of the same type with different arguments. And the only thing it looks at is the type here. So this is 3 arguments, 2 ints and a string. So that is different than this with no arguments. So now when you make a can, if you know what those values are, I'm giving you a shortcut. So if I know, hey, this can is Coke 0, then I can say new can given Coke 0, Coke 0, 355, and 0, right, for max and current. Oh, no, I'm out of order. Shoot. What's the order? It's max, current, and then name, I think. I can never remember, so we could go look at the claim. Yeah, max volume, current volume, and then beverage name. So sometimes it's hard to remember, but that's okay. So now if you know what they are, we can use the parameterized constructor. So I like the term parameterized constructor. It's a bit of a mouthful, but it's a constructor that takes parameters. So if you know what those values are, great. Go and ask for them in the constructor, and you can make a can. Right, so now this should run, do the same thing, but I can give it the values right from here. We get Coke, Coke 0, and then nothing, right? We haven't set it yet. So we're using these constructor methods, right? The job of the constructor is to give all the attributes values. You're going to give all of them values, right? Whether or not you have no arguments or you have arguments and you know what those values are going to be. Now, one important step here is you have to set the max first, because remember the current depended on the max being set. So it's possible if you do these in the wrong order, it's not going to do what you expect it to do, and that would be sad. Okay. How are you feeling so far? I know it's all new. It's all new stuff. It's another tool we're adding to our toolkit. Now, technically, we don't need any of this stuff to solve our problems. But again, it's going to make life easier for us. We can take all of these things about a noun, encapsulate it into one nice little class here, and then we can use the public methods that we have to access those values, set those values, get those values, interact with it here. And again, can is not very interesting. We're not going to solve any interesting problems with can. But as we look at more interesting classes, there's a lot more that we can do, and then we can essentially be able to reuse all of that logic here, so that we don't need to repeat it anywhere else we want to use that class. Right, so another thing we can do then with can, so aside from gets and sets, right, these are just boring gets and sets. Let's add a method called drink. So let's say public, how about we just have just a void method. Here we'll say drink, given an int milliliters to drink. So if you tell me how many milliliters you want to drink, let's go drink from our can. So I'm going to take my current volume in milliliters, and I'm going to subtract from it the milliliters to drink. Right? But then I want to see, hey, what if you tried to drink too much here? So we can say, hey, if my current volume in milliliters now is less than 0, let's set it back to 0. Now notice I don't have to use the this dot notation because there is no argument with the same name. I only have to use the this notation if you have an argument with the same name. That's called shadowing. You shadow the variable when you have an argument with the same name. So this variable's scope is to the method here. This attribute here its scope is to the class, right? So it's accessible anywhere in the class. The argument is only accessible inside the method. So we're just going to do some sanity checking. And then we probably also want to say, hey, if the milliliters to drink is greater than 0, I want to do this, right? If you tell me to drink a negative amount, okay, technically you can spit into a bottle. Is that drinking a negative amount? I don't really want to go there. So let's pretend like that can't happen. And we'll say, you're not allowed to do that. We invented a spit-proof can here, which would be amazing. Prevent all the backwash, right? I guess you could use a straw, right? But you need like a straw with like one of those like one-way valves on it. Or use a Tesla valve. Have you guys ever heard of the Tesla valve? This thing is phenomenal. This is totally worth your time. Tesla valve. So the Tesla valve is invented by not our car company Tesla, but the inventor, Nikola Tesla. It uses this cool idea of, Oh my goodness. Flow control. Fluid dynamics. There we go. Fluid dynamics. So that as you are trying to drink from or pull fluids from it here, it will flow very easily one direction, but not the other. So to go from this side, to drink from this side, pulling from this side, the fluid's just going to flow through, no problem at all. But if you try and drink from this side, and the fluid's on this side, as it starts flowing through, it starts back flowing through all of these little loops here, and actually puts pressure on the fluid as it's coming through. And, or actually, it can be gas too. I think you can just use this for gases. It makes it harder for it to flow through because it's putting that backwards pressure on it as you're trying to pull it through. So this is super amazing here. So we could use one of these if we wanted to prevent backwash and say, okay, you can't drink a negative amount. And really, if you're backwashing, you're not putting more Coke in the bottle. So I don't even want to call it Coke anymore. It's just spit at that point. That was a weird rabbit hole, folks. That was a weird rabbit hole. But again, the idea with our public methods here is that we get to protect the integrity of our class. Saying, hey, if you're not allowed to do this, I won't take an argument that does it. Now, another thing you're going to notice here, this class has nothing to do with system.out.println and nothing to do with scanner keyboard. A class's job generally will have nothing to do with input and output. Everything that's happening is being passed as arguments or returned as values. And the reason why is when we design our programs here, we talked about methods being able to be reused, right? If I'm going to do the same thing twice, I can make a method for it and not feel bad about myself. Same idea with our classes, right? If we're going to have this object and we're going to use it in our code, well, this class now has the potential to be reused. Maybe we can use this class in other applications. And again, for the stuff we're doing, no, it's not. I mean, let's be honest, it's not going to be that big and amazing we're going to reuse everywhere, but it has the potential to. And one of the things you don't know is how the person using your class might be using it. Now, for our purposes, it's me, or it's us, like you are using your own class. But as you get into bigger and bigger projects in the industry, you might write the class that someone else uses for their portion of a project, and you have nothing to do with anything else other than the class. You just write the functionality here, and you give it to them, they get to go do what they want with it. So they might be using it in a web application, or they might be using it in a mobile application, or they might be using it in a graphical user interface application. Nothing says that it has to be used in a console-based application where you have to use the scanner for keyboard and system out print lines. So classes should never have system out print lines and never have input using keyboard scanner, or the scanner class, right? Because we have no guarantee of how they're going to be used. So a lot of times I'll get that from people. They'll write a method like set something and it asks the user to go do something. Don't ever do that, right? The set should take an argument. So if your code that's using the class wants to go ask the user, then sure, it can go ask the user at the console. They can say, okay, enter a value and get the value here. So whatever is running here is going to determine where the input and output comes from, whether or not it's the web application or the mobile application or a graphical user interface application or a console application. Right? The class itself could care less. It just says, give me a value and I'll do something with it. So if you want to drink, great, let's go for it here. So then what we can do is, let's just do a silly thing here. Let's make this can of Coke Zero here. Let's put the milliliters back in it here. We'll print it out and let's say, how about while my Coke Zero dot get current volume in milliliters does not equal 0. Let's do a loop here. And what we want to do is we're going to say, let's go drink some. So we'll call Coke Zero dot drink. Now we have a drink method, and I'll say, how about math.random? Now let's do like times, I don't know, maybe 20 milliliters at a time, plus 1. And we want all of that as an integer value, right? So I'm going to put that all in parentheses. So all that arithmetic happens first. And then I'll say I want that as an int value. I'm going to cast that as an int. So pick a random number, 1 to 20 as an integer, and drink that amount here, and then we'll print our can, given the Coke Zero. Now again, print can is just saying can of, but now let's add in here. We'll say current volume is can.get current volume in milliliters. And again, that's getting a little long here, so let's bump it down a little bit. Now you'll notice I say can dot, and this is lighting up red. It says can't find symbol, variable, get current volume in milliliters. I didn't have the parentheses. These are all method calls, so you need the parentheses here for Java to know it's that it's a method call. So you have to have parentheses, otherwise it gets real upset here. Now when we run this, we're just going to drink a bunch randomly of our Coke Zero. So that was Coke, and here's our Coke Zero, right? So can of Coke has no volume, but can of Coke Zero, 355, 241. You see we just keep drinking random amounts here. Eventually we get down to 0. Right? Eventually we drank it all. So we got a random value of 1 here, right? That worked out. We got down to 1, and next time if I run it again, it's going to give me different values, right? Because it's random. We're going to get different numbers. Excuse me. Coke. And now I go from 9 to 0, right? We get different values in here because we're doing it randomly. But now for any given can, then, I can drink out of that can if I want. Another thing we could do if you wanted, again, totally up to you. This depends on what makes sense for your class here. We could say, if you give me a max volume of milliliters, we could assume all of our cans are full. Right? So if you make a new can of Coke Zero, and you say the max volume is 355, maybe we just set the current volume to be 355. That's totally within our ability of when we're writing the class. Whatever makes sense for how we're solving our problems here. Right? If every new can is completely full, we can put that into our code. We don't have to say, you tell me how full it is. Right? No one wants to get a can of Coke from the store with a max volume of 355 and have it only have 300 milliliters Coke. That's super disappointing. What was that? C void? So right in here. So void just means there's no return type, but there's no. It's just going to do something, right? Run some code and not return any values. Excuse me. Is that what you're looking at, Lemon? Had one name just before C. Oh, when I ran it, here my output. I had a can of blank here. That was the one we didn't set on, and we also had a can of Coke. We just entered Coke with no volume for the first one here. One of these ones. The last tab, I just passed it back in here, where I'm getting current volume in milliliters when I'm printing my can. Sorry, there's like a few second delay sometimes on the stream. It's not super instant. Oh, excuse me. Sorry, I missed mute there. So this public static void method where we're printing the can, again, anything that's in where we have our main method is going to be static. Again, don't worry too much about it. It'll make more sense as we do more. But as you read the chapter and look at static stuff, we're going to ignore it for now. But void doesn't return anything for print can. All right, sorry if I missed it, Lemon. Well, we can chat after. Oh, excuse me. Sorry, I'm going to go have to get something here in a second. So that's pretty good for classes. There's a little bit more to it. I think we'll call it good for classes here. Let me commit all this to GitHub for you. So here's chapter 7. So a little more. We can come back to it too when we get back and look at the rest of. We're going to go on to Inheritance, we're not going to do a whole lot with inheritance, so we can kind of wrap up more on classes that week as well after break when we talk about Project 3. Okay, cool. Glad you're good. So give me just a minute. I got to go get someone. My throat's really bothering me here, so I think I need some tea. And then we'll talk about the final exam, okay? So give me like 5 minutes, and I'll be right back. Put some more music on. Oh, I forgot I should put the music. Closed it. So I'll be back like in 5. Break. So we'll say it'll be 7:50. Okay, I'll be right back. Alright, sorry about that, folks. Oh, I think I'm pushing it here. I'm about spent with my throat. Alright, so we got to talk about the final exam here. So I have one showing here. So let me just, I'm going to hit preview on it, and I'm going to like print it as a PDF, because I'm going to have to redo it anyway. We have to rewrite our exams every time, because not that you fine folks would do it, but some folks like to take things and upload them to sites like CourseHero.com, which is awful and a violation of our academic integrity policy anyway. So you basically get a free point here. You acknowledging you understand the academic integrity policy for the course. It's open book, open notes, open internet, but you may not work with another person. All work submitted is your original work unless otherwise cited. You get a point just for putting your name down there. Again, cite your sources. My goal is to make it so you can't Google these questions. They're like nonsense generally. I mean, for the long answer ones. And for the quiz ones, like, just look in the book. Sorry. But the long answer ones here then, we have 3 long answer style questions. We have one about loops, we have one about methods, and we have one about classes. Okay, so the one, write a loop that asks users to enter the items they want to add to a shopping list, continue allowing them to enter items until they're done. Something with like a sentinel value, right? So like keep entering an item to your list or stop, unless, because no one's going to buy a stop or something like that. Right, a little loop here, that's 5 points. Write a method, sum of even numbers up to n, given an int number that returns the sum of all even numbers from 1 to n, including the number. Write a method to do something, some silly number stuff. And the class one. Oh, this is generally the longest one here. So write a class talking stuffed animal that has attributes for name, color, sound to make, and battery has power. Write a constructor that accepts value for name, color, sound to make. Have it set battery has power to true. So battery has power is not an argument, it just is always set to true. So when you make a new talking stuffed animal, it comes with a battery. Sort of the idea here. Get methods for name, color, battery has power. So notice there's no get method for sound to make. We're going to add a method change battery, which sets battery has power to true. We're going to add a method squeeze that generates a random number 1 to 10. If the number's 1, set battery has power to false. Then, if the battery has power, return the sound to make. Otherwise, return an empty string. So we'll just return nothing, like we're out of batteries here, right? This sort of thing. So that's the class we're going to make. So I think I need to like highlight all of this, is what I had to do. Because like the print to PDF thing doesn't usually work. You know, okay, let me just do this here. I'm just going to, I'll just make it as a document here or a page or something. It'll probably make life easier because the copy paste and print thing just looks really ugly. Let's come to content. I'll come to the midterm section here. And I'll put a new file out here for midterm practice. Midterm practice. So it'll be 15 quiz style questions. Questions, 1 point each, 3 long answer questions, 5 points each. Okay? And then we'll do a little heading here. 1 question on loops. Like, for example, here, let me go grab this one. Oh, excuse me. And then 1 question on methods, like, nice little formatting. So again, the goal is this is not a terrible 1 question on classes. Not a terrible exam is the aim of this. And it's not timed, aside from the due date, so start it, come back to it anytime you want. Okay. Yeah, so this is 15 quiz style questions, 3 long answer questions, plus the 1 and agreeing, and 1 question agreeing to the academic integrity policy lemon. Yep, it'll be exactly like that. So 30 points total, or 31 points total, right, with the academic integrity question. 1 point for agreeing the academic integrity policy. And the reason why, yep, you can save, just like the other quizzes, you can save your status, save your progress, and then come back to it later, as long as you hit submit by the due date. So it'll be due the day of midwinter break by 6 p.m. So you'll have the whole, it'll open at 6 p.m. It'll be due a week later at 6 p.m. So hopefully everything's done, out of the way. You can actually have your break If you want to get it done earlier in the week, great. I mean, hopefully you get it done that night, but there's no big rush on it there. If you want to wait a couple days, take your time on it. But that way we'll have that done. There's no project we're going to start. And you know what? I think we should just skip the lab too. I want you to have nothing to do over midwinter break. I really want that to actually be a break for you, because it's not often enough we get those. Okay, so 31 points total, really out of 30 essentially. So the quiz style, like, they're literally going to come from the same question bank. But I will grade these ones individually because I have to grade the long answer ones too, so I can't just like automatically post a grade. So I should post this. So yeah, I'll have the quiz showing soon. I have to rewrite it here before it'll show up in your quiz section here. This is just the practice, right? So that's fine. Does that make sense for what we're looking for here? Oh, I gotta edit this one more time. Forgot my favorite part. A more readable font here. We want Comic Sans. Okay. Thoughts, questions, concerns? So I know the class stuff is still kind of new. I mean, do you want to do a lab on classes so that you've had a chance to do some exercises before we do it on the midterm? I'm open to that too. I guess that's not the worst thing if we do like a small lab on classes. Tell you what, this will be our lab on classes. How about that, friends? Do you like it? I think that's good. This will be our lab for classes. Okay, I'm sold. If you folks are sold on it, I think I can do that. That way you're practicing for the midterm, right? So it's not the exact question, but you'll get a question like that. So you'll have a question on loops similar to that loop question. You'll have a question on methods similar to that question here. Okay? So let's come to the class again. And reach out throughout the week. Let me know if you have questions or whatnot. I can definitely do this one or help you out with this. So this will be lab 6 for meta or classes. So this is lab 6 classes. Those we do next week then. Okay, so this will be due before class starts. That should be fine. I'm not going to go over a solution at 6 p.m. You've got that whole time. Do you want me to go over a solution at 6? Do you want me not to go over a solution at 6? I could do that and then give you, like, this will take like half an hour, if that, and then give you the rest of the night for the midterm. Do you want to do that, or do you want to not? I'm open to anything, folks. Okay, so I'll plan to be here at 6 then next week. I'll go over the solution to this. It's like less than half an hour is the goal. We can go from there. Does that sound good? So we need lab 6 here. I need the invite link. Submit the feedback, pull request URL. And I'll have all your stuff graded, the other projects before the midterm for sure. Apologies for the delays. No, so it'll open next week, so 2/22. It'll open. It'll be due on March 1st, 6 p.m. So you'll have the entire week to work on it. I don't like timed exams, if I can help it. Here. Okay, so we got our lab here for that. Oh, excuse me. Right, I'll get all this other stuff graded for you before the midterm. Apologies for the delays there again. It's been rough, but hopefully we're getting through it. And we got just about a month left of winter, a month and a week or so, right? First day of spring is March 21st, right? So we're getting there. We're getting there for sure. And don't forget study group meetings. I already had the one today, but tomorrow, 12 to 1. And I believe the plan is to still have study group meetings next week as well. If you'd like to attend either of those, definitely encourage you to attend those. Lots of good extra practice chatting with Mr. Tim and other classmates. And they get you bonus points in your quizzes too, so definitely can't hurt. Okay, is that it then? So I'll meet back up on 2/22. I'll go over the solution to the lab 6, and then you'll have the rest of the time to do the midterm. Again, untimed, aside from the due date of before 3/1, March 1st, 6 p.m. So like if you want to take it all the way to the Tuesday of midwinter break, go for it. That's on you. If you want to get it done and out of the way, great. Then you can actually have the midwinter recess. So it'll be due 6 p.m. March 1st. Here, let me put it in here and you can actually see it. I think if I put a start date in, you can see it. Is that how that works? Let me edit this real quick. I think it'll show up in the calendar for you if I do this. So we want, come on, D2L, work with me here. Due date is going to be March 1st, 6 p.m. Start date is going to be February 22nd, 6 p.m. Okay, so you should be able to see it now. It just, because it has a start date, it won't like let you do it yet. Yeah, it's got the midterm, and we'll sync with the grade book. Perfect. So it just doesn't automatically grade because I have to rescore everything myself. Okay. Yep, random questions out of the pool. Great. Sound good? So it should show up for you. Let me know if you have any issues there. All right, any other thoughts, questions, concerns? If not, I think I'm going to go to bed. Let me know what I can do to help. I got office hours tomorrow, pretty much all afternoon. Limited on Thursday. And if you need to make appointments outside of that, let me know. I try and generally later at night after the kids are in bed when I'm feeling better. Possibly Friday night, Saturday. Oh, can't this Friday night. I actually plans Friday night for once. But over the weekend, I think I'm probably going to be around. So yeah, let me know what I can do to help. If you have questions about the midterm, please reach out. Ask me questions. I'm happy to at least get you pointed in the right direction on them. If I can't give you lots of hints or clues or anything, I'll tell you that. But if you're not sure about anything, let me know, and we'll go from there. So why don't I send you over to hang out with my friend Hermit? He is always full of positive energy, and you can go say hi. If not, you want to get started on the lab, we can go from there. Oh my goodness, I can't spell his name. There. Nope. Oh my goodness, I can't spell. I just gotta go find him here. There, this one. That one there. We'll go right there and say hi. Oh, come on. Raid. Can't spell, friends. One of those days. All right, there we go. You folks take care. I will see you around. Let me know what I can do to help. And if not, we'll have a great first half of the semester. We'll pick it back up next week for the lab review, and then we'll have a break. All right, folks, I'll see you then.